Welcome to the video. In this video, I'm going to show you that how can you build your own Arduino drone. So, without wasting any time, let's get started. So, this is my Arduino drone, which uses Arduino Mega 2560 chip, but the problem is it uses Mission Planner platform and Arduino IDE. But I wanted to create my own Arduino sketch and codes for my own quadcopter, because it feels really good when you create your own codes for your own project. As it's Mission Planner software, it was very easy, but I need a challenging task. So I want to create my own codes for a quadcopter. So take this aside, and for this build you're gonna need an Arduino Uno. Yes, an Arduino Uno. So you need an Arduino Uno. That's good. We have that. A receiver. I have FSR6B receiver, as you can see over here. Let me give you the focus. Yeah, as you can see, it's FSR6B receiver. A gyro for stabilizing your drone. I'm using MPU6050 gyro, and of course some wires. So as far we have all the components, only the thing is we don't have frame, ESCs and motors. I cannot scratch those all things from my previous quadcopter because I still like that one. So those things will become soon, but in today's video I'm going to show you that how can you read. Take this aside. How can you control your Arduino multicopter with the receiver? Of course you need to control your Arduino multicopter. We cannot do it wired. Of course we need a wireless control, so we are going to use this and take that input, read those input into the Arduino. So let's get started. Let's go on to my desktop. How can you do that? So welcome to my desktop. So for doing this thing we need an Arduino IDE. So let me show you that how can you download that thing. Wait a second. So go to your web browser and type arduino.cc. Arduino home. Go to Arduino home. So we got this. So over here we should get an option for downloading it. So let me just check out here. Software. Arduino IDE. Yeah. Now we got that. Right now. Now you need to create your account, do next. That will show you that how can show you to download it, or you can do it with this. Yeah, I should actually. Windows. Download Arduino software. As I'm using Windows operating system, so I used Windows thing. Proceed. Okay. Created. Doing it. Oh wait, man. Should show up here. Why isn't it doing that? Okay, but I'll find the proper link of this downloading it, and I'll just post that thing in the description or in the comments. If I don't, just remind me about that, but I've already installed that. Let's open the Arduino IDE. This command is used for the long-term calculations for timing. To adjust the timing, bytes are for the declaring the channel receiving input data, an integer because it's a unknown variable, so we are just declaring it in a receiver input channel 1 in integer. So over here we need timer 1, copy the whole statement, copy, paste and paste, change to timer 4, change it to timer 3, 2, and we are done with the declaring the variables. Now to create an interrupt, we are using pin change interrupt subroutine. Now this line says that if the PCInt 0 changes to the mask register 0 to the pin change interrupt 1, means if you get the input signal from the transmitter, which is the output, and the receiver takes it as an input, the receiver will send it to the channel number pin number 8, and Arduino will create an interrupt at the pin number 8, which is a digital input 8, and will return to the program to continue the task. Now the interrupt subroutine are used to do some special task. So I'll explain that later in a few seconds. So let's go into the void loop, what we can do over there. Now it's a long program, so I will just copy the code from my previous written program. I did this for just many of the people get confused that how can you declare the variable using for the for the transmitter and receiver program. So for that reason I showed them that how can you do that. So let's go on to my sketch. Yeah, this is over here. So this routine over here till now over here, it might look you funny, like B followed by 70 then 1. Now actually this whole over here from if then this token is used to calculate the pulse rising width of the receiver input. When the timer is set to microsecond pulse 0, it calculates the rising pulse, and when the stick position is to the lowest position, it will check the rising pulse and will set the bracket to true. Like over here, as I commented now, if input 0 changed from 1 to 0, if the explanation mark is given, means the statement under bracket is true. Means, and the timer 1 minus 5 microsecond pulse tell us the falling pulse width. So as the PWM signals, which stand for pulse width modulation, gives you the rising pulse, then constant, then gives you the falling pulse. Let me show you that how is that done in Paint. And T-Paint. I think it was a bit confusing for you, but let me show you that. So, right. So let's take this, or wait a second. So let's take this as voltage 5 volts. Then over here we need let's take 4 volts. and over here take it as 3 volts, and so on. And here take as time delta, actually time. So this over here is the time, and over here these are the voltage. So the PWM signal works when the voltage is up to 5 volt. It increases the pulse width, and then it will simply be constant to that voltage and drop down again, and will drop down again. Means the rising pulse is delta time 1, falling pulse is delta time 2. So now we need to calculate the time between these two falling and rising pulse. And doing this is really easy, as I told you that. How can you do that? With my code, I didn't finish to complete that code explanation, so let me jump on to that. Yeah. So to initialize this program, pin change interrupt, we need an interrupt setup routine, which is interrupt setup routine, which is PCIN 0 to vector, which will also initialize this program out here. Now this is a baud rate command. You can also use a digital write command, but it will take a lot of space and it takes lots and lots of processing power. This command will take less processing power, also give you the accurate result for your controlling. Now we cannot wait for the multirotor to receive the commands from the transmitter while doing the flight. We need it very accurate. So for doing that, we have used this set of commands. Timer equals to microsecond pulse, which I showed you like this. It is 1000 microsecond pulse. Be constant. Then again falls down to 1000 to 2000 microsecond pulse. So this is how it is done, again and again and again. So this will detect the rising pulse. And it will set the last channel to 1 and the timer to 1 to calculate the time and second microsecond pulse of the rising pulse. If the last channel equals to 1 and the statement under the bracket is true, which is a falling pulse, we'll set the last channel, which was this, to 0. And receiver input channel will be minus by the timer 1 to get the accurate result for falling pulses. So I did this for all the channels. Only thing which I added is the white print signal. So if the receiver input channel 1 is equal to is less than 1480, it will show the command. It means the pitch is in the front. And same goes if it's more than that, then it will show you back. Means the back, the pitch stick is at the back position. So if same goes for roll, same goes for throttle, and same goes for the yaw. So this is the whole program, and I hope that you have understand this program. If not, comment me below, I will tell you more. So don't think the video have ended now. We need to do more and more stuff. So stay tuned. So why PWM signals? It is because the PWM signals gives you not so many complications to code them, as I just shown you that how can you code your own receiver program. I don't think so. It was so complicated. It was so simple. Whereas you can also use PPM signals, pulse width modulation. Now you could use this or this. If you're using this, I will show you that how can you build your remote using this few seconds. But I haven't built that remote. I'm going to show you the schematic and the code maybe in another video. But our main focus should be on PWM signals. PWM signals stand for pulse width modulation. And pulse width modulation always works on delta time. So as I've shown you before, this is 5 volts, 4 volts, 3 volts, 2 volts, and 0. This is delta time 1, this is delta time 2. Now, imagine this is our remote. It sticks. Now, if the throttle is raised high, means at the front, the signal pulse will change. It will rise to 5 volts, or if the full throttle means the voltage will be high, that will be constant for few seconds. Not few seconds, it will be few milliseconds, because microsecond pulse, this whole thing is counted in microsecond pulse, and then it will fall down, means this whole thing is the thing we need to calculate for controlling our multicopter. So delta time 1 increases for few milliseconds, and drops down for after a few milliseconds. So it is really easy to use PWM signals for our multicopter, and it gives you better range. So pulse width modulation is a thing, that's why I chose it. So the next thing is, why do we need interrupts? Now, pretty much great question. So we need interrupts for doing a special task. Let's imagine this is a table, another table, and another table. If you just see and make some blocks over here and name it as program P1 as program 1, P2, P3, and P4. So this is the signals which are received by the receiver from the transmitter. So if it gets continuing, the graph maybe look like this. It won't be like this, but it will be really slow to get the pulse width modulation signals for our multirotor, and we need instant movements for our multirotor. That's why we use interrupt setup routine. Interrupt, it will cause an interrupt to the program for doing a special task. P5, P6, then P7. Then it will return back to the program and will continue for going on and on and on and on. So this is how PWM signal works and will work for extensions. So this was theory of PWM signals. So I hope you have understand what a PWM signal is. So let's do the connection of it. So this is our Arduino. This is our receiver. And we have some wires in here. So let's connect them. So for doing this, first take any of the wire. We need to give power to our receiver. So I'm going to take this wire and do it to the ground. Or do this to the ground, sorry, it looks black. Ground. Then the next wire, take any red or any color of your wire and give it 5 volts to it. As we have seen in the graph, it needs 5 volts. This is 1, 2, 3, 4, 5, 6. Yeah, this is the thing. Wait a second. Yeah, so we have power for our receiver. So the only thing is left is to connect it with the receiver. So let's connect that to the receiver. The negative is always this part over here. These lines, these pins here. So let's connect that to them. It's done, and the positive 5 volt is the middle, as always. So let me just do that. It's done. So as our connections are ready, we just need to connect the signal pins. So as we saw in our code, that PCIN 0 shifts to the master register 0. So PCIN T0 means pin number 8. So our channel 1 will connect to pin number 8 of the Arduino. So this will be connected. So channel 1 connected. That will go for same as channel 2, 3, and 4. So channel 3, sorry, channel 2, which is this one. That one. Then we need pin number 10. As our program says, we need pin from 10 to 11 for our receiver input channels. So it will go for third channel. And the last wire for our channel 4. So I have that wire for, wait for a second.